This Falcon 9 just flew a never-before-seen trajectory, the new engine for SLS has completed testing, and China wants to partner with the US? I'm Elysia Segal for NSF. It's Friday the 23rd of June, and there's much more to come this week in spaceflight. NASA has completed qualification tests on the new RS-25E engine for the Space Launch System. Now, as you probably know, the core stage of SLS uses the RS-25D engine, which was carried over from the Space Shuttle program, although shuttle huggers might call it the Space Shuttle Main Engine, or SSME. Now, after the end of the Space Shuttle program, only 14 RS-25D engines remained for use on SLS, and another 2 new engines were made from leftover parts for a complete set of 16 engines. Each SLS core stage uses 4 of these, though, so after 4 flights, there'd be no more RS-25 engines left to use. So NASA granted Aerojet Rocketdyne, the company that makes these engines, a contract to restart production of the engine. However, this time the engine would be upgraded with several new components and adapted for use specifically as an expendable engine for SLS. So this new engine, the RS-25E, started its qualification campaign on February 8th this year, and it's since completed 12 test fires to evaluate these new changes. Some of these changes included an increase in thrust as a result of the reduced need for structural margins on the expendable engine, simplified plumbing via a reduced gimbal angle, and the use of additive manufacturing on certain parts of the engine, which has reduced the part count and the cost of the engine. So, what does this mean for SLS? Well, it means that starting with Artemis 5, the rocket will have a higher performance capability, and it'll leap off the pad a bit faster. But don't hold your breath for that just yet, as this mission may not happen until the end of the decade, or perhaps even into the early 2030s. But it is very cool to see this engine breathing fire, even if for the time being, it was just on the test stand at Stennis. The BepiColombo probe, a spacecraft developed by the European Space Agency and the Japanese Aerospace Exploration Agency, flew by the solar system's innermost planet, Mercury, earlier this week. Closest approach occurred on June 19th at 1934 UTC at a mere 236 kilometers above the planet's surface. This is the third of 6 flybys that the spacecraft is set to perform around Mercury before entering orbit around it. The spacecraft launched on an Ariane 5 rocket in December of 2018. Now, it sounds counterintuitive, but the energy required to reach Mercury is actually much higher than the energy needed to reach Pluto, for example. For this reason, the spacecraft not only needed ESA's largest launcher to send it to Mercury, but also to execute several flybys of planets in the inner solar system. BepiColombo first performed a flyby of Earth in April of 2020, followed by 2 Venus flybys in October of 2020 and August of 2021. After that, the orbit was already low enough to encounter Mercury on a first flyby that occurred in October of 2021. The second flyby occurred just last year in June, and now we've just seen its third flyby of Mercury. Another 3 more are set to occur in September of 2024, December 2024, and January 2025. The probe will then enter orbit around Mercury in December of 2025 and study the planet in detail with its scientific instruments. Now, these instruments are already being put to the test during these flybys, allowing scientists to monitor their health during the long travel needed until the start of the science portion of the mission. The most interesting thing about this probe is that it's actually 2 probes in one. After orbital insertion around the planet, BepiColombo will separate into 2 orbiters: the Mercury Planetary Orbiter, developed primarily by ESA, and the Mercury Magnetospheric Orbiter, developed primarily by JAXA. Each of them are equipped with different instruments and will study Mercury in different ways and even different orbits, allowing more science to be gathered. This means that, hopefully, in just 2.5 years, we'll have not 1, but 2 orbiters around Mercury, all from one single launch. How cool is that? Now let's go over this week in launches. This week, we saw the launch of Rocket Lab's first HASTE rocket. Liftoff occurred on June 18th at 1:24 UTC from Launch Complex 2 at NASA's Wallops Flight Facility in Virginia. The launch, carried out mostly in secret, was later revealed to haul the MACH-TB vehicle developed by Dynetics. MACH-TB stands for Multi-Service Advanced Capability Hypersonic Testbed, and it allows Dynetics to offer it as a service to test hypersonic systems on this vehicle. Not much more is known about this program or when the next launch of HASTE could be, but you can be certain we'll keep our eyes peeled for what happens next. Moving to launches which we have video of, this Falcon 9 rocket launched on June 18th at 22:21 UTC from Florida, carrying the PSN Satria satellite to geostationary transfer orbit. The first stage of this mission, B-1067, was flying for a 12th time and landed on SpaceX's drone ship A Shortfall of Gravitas. Satria will serve Ka-band high-throughput communications to Indonesia and will be operated by Pacific Satellite Nusantara. A Chinese Changzheng 6 rocket lifted off on June 20th at 3:18 UTC from Launch Complex 16 at the Taiyuan Satellite Launch Center. The rocket was carrying the Xi'an-25 satellite, which, according to Chinese government officials, is set for testing new Earth observation techniques. Maybe that's their expression for spy satellite? Another Falcon 9 launched this week on June 22nd at 7:19 UTC from Vandenberg. The mission carried a batch of Starlink V1.5 satellites to Starlink's second-generation constellation, or Starlink Gen 2. This was the first time a mission dedicated to Starlink Gen 2 took place from Vandenberg. This also meant that the rocket needed a very interesting dogleg maneuver around Baja California to reach its 43-degree orbital inclination. This makes it the lowest orbital inclination ever achieved from the US West Coast, something nobody else has ever done. The booster for this mission, B-1075, was flying for a 4th time and landed on SpaceX's drone ship Of Course I Still Love You. This launch came at 9 days, 9 hours, and 44 minutes after the launch of Transporter 8, marking a new record turnaround time for this launch pad. 47 Starlink V1.5 satellites were launched on this mission, bringing the total to 4,642 satellites already launched. Of these, 4,312 remain in orbit, and 3,688 are in their operational orbit. This week, we also saw the launch of the mighty Delta IV Heavy on its penultimate flight. Liftoff occurred on June 22nd at 9:18 UTC from Space Launch Complex 37B in Florida. The rocket carried the classified NROL-68 mission for the National Reconnaissance Office. While not a lot of details are available about this payload, it is likely an Orion reconnaissance satellite that was launched directly into geosynchronous orbit. Now, this was the penultimate launch of the rocket, with its last launch currently set for no earlier than March 2024. The launch left us with incredible shots of the rocket setting itself on fire and thrusting off into space with the power of its 3 RS-68 engines. Rocket factory Augsburg and PLD Space have signed agreements with the French space agency CNES to launch their rockets from French Guiana. The launch pad in question would be the one used for the old Diamant rocket developed in the 1970s. Rocket factory Augsburg already had plans to launch its RFA-1 rocket from Saxavord in Scotland, but by adding this new launch pad closer to the equator, it is now able to deliver satellites to lower inclinations. This will allow the company to offer a wider range of missions to the customers and add launch capacity for its schedule. For PLD Space, this will be the first launch pad for its Miura-5 orbital rocket, which plans to start launching next year from this location. The company is currently using a launch pad in Spain to test its suborbital rocket demonstrator, the Miura-1. Now, Alex says that if you look at Spain on the map, you can see that it's really hard to launch to the east and still be able to put something into orbit, unless, of course, you want to drop rocket stages on people. Well, this is true for the rest of Europe in general, unless, of course, you're in places like Saxavord and launching to the north, and then you're generally okay. So, now you can see why the Guiana Space Center is called the European Spaceport. It offers a wider range of access to orbits that European companies can use to launch from. This week, we saw China partnering with NASA and other space agencies to use their lunar relay satellite. Launched in May of 2018, the Tuochao lunar relay satellite was originally intended to be used as part of the Chang'e 4 mission set to land on the far side of the moon. Now, as you probably know, there's no way to communicate directly with this side of the moon, hence the need for this relay satellite. However, it's seen many uses other than that since it's launched. I mean, think about it. A relay satellite that can communicate with the only part of the moon that we can't directly see. Well, of course there were many more potential needs for it other than that mission. This relay was also used during the Chang'e 5 lander mission back in 2020. Although it didn't land on the far side of the moon, it did fly over that side during its stay in lunar orbit. According to the China National Space Administration, NASA and other space agencies had requested the use of this relay satellite for their future lunar missions. Now it says that these requests have been accepted and will allow the use of the relay satellite for these missions, citing, quote, "China is open and cooperative." With the current geopolitical situation, it's hard to see any sort of cooperation between NASA and China, especially when there's a law limiting this cooperation. So, what do you think? Will this actually happen, or will it just be something merely symbolic? And now let's go over next week in spaceflight. A Soyuz 2.1B with a Frigate M upper stage will launch the Meteor-M No. 2-3 satellite from Site 1S at Vostochny. Liftoff is set to occur on June 27th at 11:34 UTC. Along for the ride will also be 29 small satellites. Next week, Virgin Galactic is set to begin commercial customer flights of its Spaceship Two vehicle. The mission, dubbed Galactic 01, is set to take place on June 27th. No times have been released as of yet, but based on previous flights, it will probably take place in the morning local time. The CRS-28 Dragon spacecraft is set to return from the ISS next week. Undocking is set for June 29th at 16:05 UTC, with splashdown set to occur later in the day. And that's your weekly update of spaceflight news. Don't forget to watch our latest KSC flyover that was released just earlier today. That should pop up around here. Or maybe you're more of a Starship fan and you want to catch up with the latest Starbase update. Well, that should appear right over here. So everyone, thanks for watching, and we'll see you all again next week to recap this week in spaceflight.